that going. Awesome. All right. So, hey everyone, welcome to week 1, day 3 of Uniform. I know things have been a little bit intense. That is definitely not going to change. But hopefully we'll get to have some fun today. So let's go pop into, oh no. Why can I not pop into VS Code? There we go. Okay, perfect. So hopefully you guys can see my VS Code screen relatively okay. If not, let me know. So, as I'm sure you guys have seen on the calendar by now, today we're going to be talking a little bit about JavaScript. Um, so this should be stuff that you're relatively familiar with, at least, let's say the first hour to hour and a half of material should be review from the pre-work, but a little bit of review never hurts because it can help wrap up some deficiencies if they exist, allow you to ask questions, that sort of thing. And then after that, we're going to launch into some more advanced JavaScript, or I guess intermediate level JavaScript stuff, and then break for lunch, and then you guys will have your Beyond Tech and challenges. So to start things off, we're going to talk a little bit about how the intranet works. So the intranet is basically has four, I guess you could say four main components. So components of the intranet. Nope, not intersection observer entry. Don't know why it said that. Internet. I do not need autocorrecting here. Okay, actually, you know what? Here, let's just make a text file. That's probably a little bit easier. And I don't know why that decided to make it into JavaScript. Okay, in any case, there's four like essential components that we're going to be talking about today. So the first one is going to be like the customer slash you slash the user, which is basically the person with a computer. That's going to interface back and forth with something called a web server, which is then going to interface back and forth with something called an application server. And then that's going to interface back and forth with something called the backend. So this first part, the customer, user, and web server, is what we think of as the front end of web development. So essentially, the moment that you open up like Google, you, the user, are able to interact with the Google web page, which is essentially hosted on Google's one of very, very, very many web servers. So the places that you can like type things, click, see hyperlinks, that's all part of this first half of the front end. And we sort of conventionally think of the back end as the area where all of the stuff that you don't see happens. So, for example, if you were to go to Google right now and you type in, how to do hello world in JavaScript. So you are typing and interacting with the front end through that web server, through google.com. But the moment you hit enter and that how do I say hello world in JavaScript gets sent to some piece of code in the back of Google, like their API or applications, and that runs on their server. That then goes to their backend databases. Change that. With like the millions of or billions of entries that Google has, runs through, pulls out the answer that you need, takes that answer to another application server, which then spits it out to a web server, which is basically your web page. And then that web page shows you all the results for your query. And then that puts it back to you, the user. So again, here we can just broadly say front end goes up to like here. And then this part is like your back end. That goes here. And again, so the front end is stuff you see, interact with directly. Nope, directly. And the back end is sort of like your data manipulation / stuff you don't see. So any questions about that? Okay. Here, hang on. Let me just copy. Perfect. Okay, so now we don't have that mess. Okay, great. So now we have actual normal text, which is good. So what is JavaScript? JavaScript is something that sort of allows us to interface between the front end and the back end. It's something that we can use to make web servers. It's something we can use to interact with web servers, to interact with applications. So JavaScript kind of fits like in the middle. Um, and I guess also before that, did the explanation that I gave about how this sort of four-step framework makes sense? Or are there any questions about that bit before we continue?
Made sense.
Okay, cool. Also, just so you guys know, the chat does not automatically pop up for me in when I'm sharing my screen in Zoom. So if you guys do have any questions, just feel free to like pop off mic and say your question. That's totally chill. All right, so let's get to talking a little bit more about the details of each of these parts of our of the internet. So the user is pretty much self-explanatory, right? That's just like the person sitting on the other end or the computer that you're using to access stuff. Now the web server is the way that we can display data in a user-friendly manner. In a user-friendly manner. And we can do this using HTML or hypertext markup language and CSS or cascading style sheets. And this is something that we're going to cover in, I think, about 2 or 3 weeks from now. But HTML and CSS are basically like the bread and butter of your web pages. So if you go to Google, for example, everything that shows up on that Google home screen is coded in HTML and CSS. Now the HTML is basically like the part that shows you your hyperlinks, that gives you like embeds images, and the CSS is sort of like all the fancy parts. The CSS is like the colors and the fonts and so on. The only problem with HTML and CSS is on their own, HTML and CSS are static. So they don't really change and they don't really, it's difficult for them to take in input. So HTML and CSS, like just on their own, are really good if let's say you're making like a dictionary website or like Wikipedia to like, but a really bad version of Wikipedia where it just has a list of articles and the list of articles is fixed and you can click an article and you can see a bunch of stuff about the article. HTML and CSS are great for that, like on their own. But let's say that we wanted to do something more. Let's say that instead of just having that static list of articles, let's say we wanted to give people the ability to write their own articles and post them to the site. Or we could have a feature that allowed people to make accounts on your website and then bookmark their favorite articles, or even just like posting comments. So all of that stuff would change the web page every time you went to it. And that's not something that HTML and CSS allow you to do on their own. So that is where JavaScript comes into play. So JavaScript helps you make web pages, I guess you could say, less static or dynamic if you wanted to use a fancier word. So it lets you do things like take in user input. It lets you respond to user input. It lets you change elements of your web pages. It lets you interface with applications. You can use it to pull data, to create new data. So JavaScript kind of helps you with this middle bit of interfacing between that front end and the back end. So this is in a little bit of contrast with Python, which is another language that you guys have seen and that we'll be using very extensively throughout the course. But Python more or less tends to live a little bit more in like the back end half, whereas JavaScript is sort of like a little bit more of the go-between between you typing and whatever is going on in the back end. So I give a very general overview of JavaScript and its history. So this is stuff that you guys will also be able to read in more detail on the README for today. But basically, JavaScript's origins are pretty closely related to Mozilla, aka the browser that made Firefox. So if you look at like documentation for JavaScript, a lot of the time you'll see documentation coming from Mozilla. So that's kind of why. Also, interestingly, the original name for JavaScript was supposed to be Mocha, but apparently they didn't like the sound of Mocha very much. So they decided to change it to JavaScript, which I guess are both coffee related. But interestingly, there is another programming language called Java, which is somewhat similar to C and Python. But despite JavaScript and Java having like very similar names, there is no relation between the two languages. So yeah. Okay, so back to JavaScript itself. So JavaScript helps you make your web pages more dynamic. It lets you take in, it lets you do things like you can update HTML/CSS. You can pull data from a backend. You can get user data. Let's see, like interface with other applications. And there's like a lot of other things that we can do with JavaScript. But it's super helpful for us as programmers because it lets us do more stuff when it comes to our web pages. Also, JavaScript is generally like a relatively user-friendly and efficient language. So there isn't a lot of boilerplate that's needed. Let's see, can Python be used instead of JavaScript for front-end web development? That's a good question, Dale. I know that I have definitely seen Python used for like mobile app development before, and I'm fairly sure you can use it for front-end web development. However, Python, unlike JavaScript, Python is not purpose-built for web development. Python is more built for like data analysis. So I'm fairly sure that there are probably some Python packages out there that you can use to make web pages, but in full honesty, they're probably going to be really clunky to use compared to JavaScript. Just because Python isn't built, like the language itself, it wasn't constructed with this usage in mind.
So like if I wanted to like play around with data like on the front end and be able to see it, could I use Python then just for like maybe my own personal application development?
Yeah, so this is something that we're going to cover very extensively in probably like week/module, like I'm gonna say 5 or 4. So in a little while, but not too far along. But basically, a lot of what we are going to end up doing for full stack web development, which is essentially full stack web development for us, basically just means how do we connect user to backend and make it look good? So like this whole process. We combine all of this stuff together. So you'll use like Python to sort of go to your databases and pull stuff and get data and play with it. And then we'll use JavaScript to sort of help you display that data on a web page or take user input and stuff like that. So we will basically combine everything in order to do that. So hopefully that answered your question. All right, so next up, does Python have an async await functionality? Let's see. Rob, that is a good question. I'm actually not sure. I don't believe it does have something similar to a promise, as far as I'm aware, just because that generally isn't super helpful. Oh, Francisco, go ahead.
Oh, yeah, sorry. Python does have an asynchronous function, but Python itself is already structured to work asynchronously, meaning that it won't move on to the next block or line of code until each individual line is completed. The asynchronous function that's offered for Python is mainly utilized when you're trying to test blocks of code, and that's when it actually comes in handy. But other than that, know that the difference between one of the biggest differences between JavaScript and Python is that JavaScript, you need to explicitly tell it this is going to be an asynchronous functionality, while in Python, it already knows that every single line, it shouldn't move until the next line, until one line of code is fully functional and completed.
Thanks for that explanation, Francisco. I guess that explains why I hadn't seen the async function in Python before. But also something, if you ever look at like Python editors, things like say Jupyter Notebooks or Google Collaboratory, something that they'll do that JavaScript doesn't, that I guess sort of helps explain the Python async bit, is you can set up your code in blocks and run blocks of your code like individually. So nothing can run at the same time, but like if you have like 300 lines, for example, you can set up like the first 50 in block 1, then the next like 3 functions in block 2, and so on, and run each of those blocks on their own. Let's see, any other questions? So yep, so Jonathan, as Bennett said, JavaScript is kind of both. And it's right now for us, we're going to start by mostly using it in the front end, and then also learn about how to use it to interface with the back end. And yeah, as Rob mentions, there are libraries that let it do a lot more back end stuff using things like Node. But for right now, like for the context of today, we're just going to think of JavaScript as being something that sort of lives in the middle of everything. But yeah, any other questions about how JavaScript and Python fit into this framework? Okay, if not, so we're going to start moving on to the actual coding part of today. So the first thing we're going to talk about is something that Francisco already mentioned in chat. So this is a great transition, which is Node.js. So Node.js is a implementation of JavaScript that essentially allows us to, so lets us write JavaScript code for the back end. So what do I mean by this? So remember how I said above that JavaScript helps you make web pages less static / more dynamic? Well, normally when we write JavaScript, it's almost always in the context of a web page, which is great, but if we're just trying to create functions that add 2 numbers together, we don't want to have to build out a whole web page for them. So what Node.js lets us do is it lets us write JavaScript without needing to tie it to a specific web page. And it lets us interact with things like databases or other servers without that one web page. So how do we access Node.js? Well, if you're in your terminal, which I always recommend at the start of class to just like open up a new VS Code window and keep it open because you never know what stuff we're going to be coding today. So open up your VS Code and go to your terminal and just type in Node. And as you can see here, you say welcome to Node.js, and it's got my version, it's got .help. And this is basically how we can write JavaScript in the backend. So if I wanted to say, for example, console.log hello world, and I ran it, then as you can see here, it runs that JavaScript code in Node, and it says hello world in my console, which is great. So let's exit that. So does everybody have Node.js installed, or did anybody have problems installing it before I move on to actually using it? Okay, I'm going to assume not. So that's perfect. So let's go back to my very empty JavaScript demo file. So this next part, I'm going to run through it fairly quickly, just because this is mostly stuff that was covered in pre-work. That being said, please do not feel shy about asking questions. If you have them, pop them in chat, unmute, because again, this part is review, but the review is not meant to just be stuff that you fully understand. If you have questions, please ask them. Also, if you guys want to, feel free to code along with me on your own and test the code or play around with the examples I use. I've personally found that's a really great way to learn a language. So you guys are more than welcome to try that out as well. All right, so kicking things off. The first thing that I always like to talk about in JavaScript are the data types. So we have a couple of different data types in JavaScript. The two main categories of data types are going to be primitive and complex. So just from the words alone, what do you guys think what do you guys think a primitive data type is?
Like integers.
Yep. Anybody else?
Single element like numbers or like character.
Yeah, pretty much. So primitive data types are basically like built-in data types in JavaScript. They are immutable. So their definitions can't be changed. Here, let me also just make this more of a note. There we go. What else? And they also like self-evaluate. So if you run like an evaluation command for that data type, and you say, hey, what data type is this? Instead of giving you some random weird string relating to a memory address, it'll just be like, hey, this is an integer, or this is a float, etc. So what are the types, the primitive types in JavaScript? So we have strings, we have numbers, we have Booleans, we have our special, undefined, and null values. And we'll get into how each of these work in a little bit more detail very shortly. So meanwhile, now that we've done primitive data types, what do you guys think a complex data type might be? Or what's the difference between?
An object.
Yep, an object is a really good example. Anybody else?
Method.
Yeah, objects, arrays, hash maps. There's a bunch, and we'll get to these probably today, to start, and then we'll really start talking about these a lot more going into next week and after. So, but before we go to the examples of complex data types, so a complex data type is essentially a data type that contains other data types. So, for example, if you have an object will generally contain a bunch of strings. It'll also contain a bunch of, like, it can also contain numbers and Booleans and undefined values and nulls. So it can contain a lot of other data types. Also, because it contains all these other data types, complex data types are also usually mutable, unlike primitives. So their definitions can be changed. So if you think about it in context of, let's say, like an object, right? So if I give you an object, I can add on key value pairs to that object. So that makes it mutable. So it's a complex data type. And also, because I can add key value pairs without restriction, it can contain other data types, which also makes it, again, complex. That's about it for now. We'll get to more details on this later. So first, though, let's start off with primitive data types. So we've already covered some examples, but let's talk a little bit about strings to kick this off. So a string is basically anything within two quotes. So we could say like string 1 equals I am a string. And we can also say within single quotes, I am a string 2. So one thing to note, stylistically, it's up to you whether you like using double quotes or single quotes. There isn't really a difference in terms of the code that we're using for JavaScript. But please, please, please do not use both definitions in the same piece of code, because it just looks really ugly to have double quotes in one place, then single quotes in another, and then double quotes again. Stick to one and stick through it all throughout. Something else to note is JavaScript and Python are okay with you using double quotes and single quotes interchangeably, but some other languages only use single quotes for like single characters. So if I just type like O or like the number 3 in those single quotes, that would only be the only acceptable use of them. So you would, in other languages, you wouldn't be able to type multiple characters within single quotes. That is not the case in JavaScript, but that may be a good practice. That's at least personally what I do, is I always use double quotes for things that aren't just one character. You're welcome to do that if you'd like, but if you don't want to, again, feel free to use them interchangeably. That's totally okay. Another thing to think about, Jesse, that's a good question. C is the main language I'm familiar with, and C++ as well, because those are languages that are very rigidly structured. So they tend to have a bunch of additional rules. So I originally learned C before JavaScript. So that's sort of why I usually come at this with I'm always going to use double quotes until I have a single character. Once I find a single character, then I'm just going to use a single quote for that. In addition, we can also do something called string interpolation in JavaScript. So this is similar to F strings in Python, if you guys have seen that. So we could say interpolated string, and that uses backticks, which I'll admit is a little bit weird, but also backticks look really similar to single quotes, so keep that difference in mind. So you could say something like, this string has numbers in it, and then instead of typing out the numbers, we'll put a $sign and then curly brackets, and then the stuff inside that we want to interpret. So if we want to say like 1 + 2, for example, the interpolated string here should evaluate to this string has numbers in it like 3. But don't just trust me on that. let's actually run this file. So let's grab my mouse and we'll console log, which is the same thing as print in Python or interpolated string. If we run this, you can see that it says the string has numbers in it, and then it has 1 plus 2, which is 3. Now, similarly, we can also just use interpolation for putting in numbers. We can also use it to combine strings together. So what I could say is something like hello, my name is, and then we can put in, let's say, like a name, and then we can also put in string 2. And let's say that we create some name that is like Boomer, and I run this again. So it says again, hello, my name is, and where we have this $sign and curly brackets, it goes and says, all right, where is name? Name is here. This is a string, so I'm going to pop that in there. And it does the exact same thing for string 2. So it goes and says, all right, I have my $sign. That means I know that this string, and that I need to put something in my string that is a variable. What is a variable? String 2. What's the value of string 2? I'm string 2. All right, let's put that in. And then we console log it. It combines all of them together, which is very helpful. So any questions about interpolation?
Why is name crossed out?
Good question. So let's mouse. So generally, whenever something is crossed out or squiggle lined or anything like that, it's always a good idea to mouse over it and read what it says. So what does this one say? All right, the name is deprecated. The deprecation was okay. So what this means is name used to be a special value, sort of like null or undefined, or name was related to the name of, or like a function. But that function or special variable, special name isn't in use anymore, so we can use it now. But that also means that calling this name is not generally a good idea because, again, it says it is deprecated in this version, but in previous versions of JavaScript, it might not be. So we could say something like, instead of name, replace it with this construct, my name. And then the squiggly line goes away because my name was not a protected variable at some point. Rob, you do not always need to declare your variables with let. You definitely can, and that won't cause you any errors. But you do not have to do that. Let's see what else. So yeah, just here. Let me also just jot down string interpolation. Backticks around the string plus $sign thing you want to interpolate.
Are you able to run functions in there as well in that interpolated string?
Yes, you should be able to. So again, let's say I can't think of anything off the top of my head right now, but what we could say is again like addition is a function, right? So we can say like 1 plus 4 plus 7 plus 5, because those are functions. And if we run this again, you see that this goes to 10. Why? Because it evaluates whatever is inside of those curly brackets and converts it to a string. So you can run functions inside of those curly brackets. Would I always recommend it? It depends, but yes, to answer your question, Nicholas, you can run functions inside of your curly brackets.
Okay, thanks.
Yep. Let's see. So, okay, let me catch up on the chat really quickly here. Is there a time when you have to declare let? I don't think so. It's generally good practice to use let though. but it's not something that's always required. You'll generally see let being used in things like for loops, or if you're creating like a variable that's important for the rest. But if you, I believe, Kristen, you're correct about if you don't use let or const, then it is treated as if we used let. And we can see that here as well. I mean, if we wanted to, I could put lets before all of these variables, and ideally, this should still work, and it still does. To comment on the difference between let and const, which is an important one, the const stands for constant. So not in JavaScript and in other languages, if you declare something with a const, that will in general make it immutable. So let's see an example of that here. Let me remove this. So if I were to say const, let's do another string. Let's say string constant equals, this is a constant string. And now strings are at their core arrays. So you say strings are arrays. Let me just also say that. And why is, okay, let's stop. There we go. So if I were to try and change the value inside of const, we could say something like string constant 0 equals h, which would change the character. And we can console, nope, I don't know why I did that. Console log string const, run that. It still says this is a constant string. Why? Well, again, because we use the const keyword, which makes this immutable. But also strings are immutable on their own, but the const keyword just reinforces that and says this thing is going to be constant. This will not change. So const is used to keep a variable constant or immutable. Any questions about that? Okay, I'm going to,
Is
go
there any
ahead.
point to using const on a string when a strings are always immutable anyways?
It's good practice to, especially just so that you can remember that that the string is immutable. Yeah, that's what I would say personally, is use it just to remember. It's not necessary to use it, as we saw above, but you can use it if you want to. And Zekun, that's a good question. So you can use semicolons in JavaScript, and that's something that we're going to get to a lot more later. When you're typing things out in a JavaScript file like I am right now, you don't need to if you use the enter key or return to space out your lines. But let's say that I'm typing a bunch of JavaScript in one line, which is something that we can do and that we will do a lot more in HTML. But let's say that I am going to put all of this in one line, like so. This doesn't work because it doesn't know how to demarcate between what I was calling the first line and the second line and the third line. In order to do that, we use semicolons to space out the lines, like so. So this is where semicolons comes in handy. It can be good practice to get in the habit of using semicolons starting from now. Just so that, again, later on, when we're writing JavaScript, like multiple lines of JavaScript in one line, it's already built in that we start semicoloning. But again, if we are using something with multiple lines, you don't need semicolons. So hopefully that makes sense. Let me catch up on the chat one more time. Yes, so yeah, Dave, you are correct. So with const, you can't reassign the variable later on. So it sort of locks it in place and again sets it as a constant. Okay. What other things are important to talk about with strings? So there are some string methods that we can talk about as well. So string methods are things like, let's say I have we can turn strings uppercase and lowercase. So we can do that using 2 upper and 2 lower. So I can console log, let's say, let's change this to capital T. And we've got string constant dot to uppercase. And if we do that and run it, it turns the whole thing uppercase. If we can do it the other way. Okay, let me just make that a new line. We'll just say we turn this into lowercase as well. Again, same thing. It just turns the entire thing into lowercase. We can also slice strings. So string constant dot slice, and we can start slicing this at, let's say, like the first character, and we can end it, or a character with index 1, we can end it, say a character with index of 4, and then that'll just return characters. So 0 is T, so it won't do that. 1 is H, 2 is I, 3 is S, and then they'll stop there, and they'll return HIS. That's about it for string methods. Any questions about strings in the meantime? All right, so no questions on Mike. Let me catch up on the chat one more time. When you constant array the variable, yeah, as Dave says, the variable that you assign to that array will always lock it, but also that way you can't change what the variable points to. So const kind of locks it in terms of what it's referring to and in the memory. Let's see, we can split. Yes, so Roger, you can split strings into an array, and you can use the split function to do that. That's the main way that we can do it. However, also note that, as I said above right here, strings are at their core basically arrays. And we'll see this in Python too. Strings are essentially lists of characters. In other languages like C, they are explicitly one and the same. So we can use array/list notation to access their characters. Yeah. All right. Any other questions? If there aren't any other questions, we'll cover numbers real quick, and then we'll take a 5-minute break, and then we'll jump back into things. So, or I guess we can probably do numbers and Booleans. So here, let me just comment this stuff out, so that way I don't get a bunch of console log statements showing up in my console when I run things. Perfect. All right, so let's say numbers. So numbers are pretty simple. We've seen numbers before. They're just, again, you've got your integer types, floats, doubles, big ints, etc. However, JavaScript doesn't really, okay, wait, technically, yes. Grace, that is a really good question. The answer is not exactly. So you'll find like if you look up, say, like a JavaScript style guide, you'll probably find at least a couple. They'll all have like some common points, like indent your code or use semicolons, but they don't always say the same things with details, like saying always use let versus var. So to answer your question, there isn't really one Bible to use. There are generally a bunch. So if there was just one, that would make it a lot easier. But unfortunately, there isn't. That being said, sometimes for a given language, JavaScript does not, or JavaScript, well, the docs on occasion will do this, but if you need help like with syntax for a specific object or like file structure or something, go to the documentation and they'll tell you the official practice for how to use whatever thing it is you're trying to use. However, the documentation is often kind of long and complex and not fun to deal with. So if it does provide style in the documentation, use that. Otherwise, just look up a style guide. If you see something that either tracks with what we have talked about in class here, or something that makes sense to you, adopt that into your personal good practices and bad practices, but there's unfortunately nothing official for that.
So just something to kind of feel out with experience and practice and that kind of thing.
Yeah, exactly. But also as you get more time with programming in various languages and also paradigms, you'll learn more about different ways that or different things that are best practices in various languages, especially as we get into like dual using Python and JavaScript for the next few weeks. You'll notice like a lot of similarities between how we do things in those. And through that, you'll basically be able to figure out the best possible, or I wouldn't say the best practices, but like good practices that are consistent across both. And similarly, once you guys enter like the apprenticeship or job field, you'll probably also get tips from like your supervisors or look at the code that your coworkers are using and such. And it sort of becomes like a big conglomeration of good stuff that you've learned from various sources at the end of the day.
Cool. Thank you.
Yep. But also, I guess one other thing I should mention is, especially for languages like JavaScript and Python, but also for things like Ruby or C or MATLAB, there are often like a bunch of textbooks on the web that are just like, or like giant physical textbooks that are just like, here is how to teach this language. Oftentimes those will also have style guides in them, and also help you learn the language if you choose to use those. And yeah, Jonathan, yes and no. So like some things will be consistently good practices, like saying, all right, either use when you're creating variable names, either use camel case or use underscores. Do not type your variable names like your name. Please do not name your variables this way. Either name them like so. Nope, not that. Your name like this or like that. I mean, that's generally a good practice. Like that's something I'm pretty sure anybody in any organization will tell you to do. But which of these two to use, it'll probably depend on the specific application or team that you're in. So in general, like good practices are fairly consistent. Sometimes they'll vary a little bit, but yeah. Yep. Okay. So let's go ahead and just talk about numbers really quickly. So in some languages, again, I know some of you guys mentioned C++ and Java. those have separate designations for integers or floats, which are decimals. JavaScript puts everything under the same bucket. It's JavaScript says, all right, everything is a number. So note also that we're not going to really talk that much about numbers because they're pretty self-explanatory compared to strings and other data types. So everything int, float, double, big int is a number at heart. Also note that for numbers that get kind of either really big or really small, they will use condensed scientific notation. So if I sometimes if you'll write out like a decimal that's like got a bunch of zeros in it, expect it when it's printed out or returned to you to be returned in scientific notation format. So that's something that you should be relatively familiar with. Let's also just talk about Booleans real quick, and then we can take a short break. So Boolean values are either true or false. Note, in JavaScript, the true and false are written in all lowercase. Oh, actually, yeah, let me back up to the scientific notation part. So the scientific notation is basically, let's say that I have, let I am a decimal be like 0.0 or 0.0000123. So I'm a decimal is a number, but we can also represent here, let me see if I can console log I am a decimal. Okay, well that shows the console log it normally, but we can also write this in scientific notation. So this will happen a lot for either really big numbers or really small numbers. So the way that we can convert this into scientific notation is take everything after the zeros, which is going to be 1.23. Then we use an E to denote that this is scientific notation. And then we basically count backwards from the decimal, so it's going to be 1, 2, 3, so E -4. Let me just say I am a decimal 2. And if we console log that, as you can see, these two are the same thing. So this I am a decimal 2 is just I am a decimal written in scientific notation. We can also do scientific notation for giant positive numbers. Like if we had something in the millions or billions, oftentimes sometimes JavaScript will output it normally. Sometimes it'll output it in scientific notation, depending on how big the number gets. So this is something good to keep in mind when working with numbers. Let me also just write this. Nope. Scientific notation is a thing. All right, so let's just talk about Booleans real quick. So Booleans in JavaScript are either true or false. That's really about all there is to them. Also, JavaScript does something called short circuiting. Let me write this down. So short circuiting, it will only evaluate as much of an expression as it needs to know whether the whole thing is true or false. Here, let me space that out. So if I create something that is, let's say, what would be a good example of this? Here, yeah, so let's say if I have like an OR statement. I say Boolean 1 or Boolean 2. Right, so this is going to be our expression for, let's say, 2 random Booleans. So JavaScript, so how do I know if in what situations is an OR statement true? Let's just start there.
So that's if either Boolean statement is true or both Boolean statements are true.
Yep. So or is true when either or both Booleans are true. So what JavaScript is going to do is going to say, is Boolean 1 true? If so, I don't even need to check Boolean 2 and then just proceed. And now if Boolean 1 is false, then I have to check Boolean 2. So that's basically what short circuiting is for our purposes. So it'll check the first expression. If that's true, great, we're done. If that's not true, then it'll move on. Let's see, what else do I want to say? Oh, also, there's something called truthiness, which sounds kind of weird. But truthiness basically helps you convert zeros and ones to Booleans. So binary and Boolean in JavaScript are similar. So zeros are going to be falsy, and ones are going to be truthy. So if, for example, I were to have a number that was either a 0 or a 1, so we can console log here. Let's remove that. So if I were to say 1 or false, like so. So false here is obviously a Boolean, right? Because it's true or false, and here we picked false. But 1 is originally a number. However, because this 1 is in the context of a Boolean expression, because we have an or and we have a false, JavaScript is going to convert this 1 into a true, if I remember correctly, and it'll then say that this whole thing is a 1. And we can see that if we run this code, yep, 1 or false, and it returns 1. Let's see. Anything else that we want to talk about for Booleans? Not really. I think that's about it for Booleans. So let's go ahead and take a break until 9:43, and then we'll come back and keep moving forward. Any questions about anything at all so far? Okay, enjoy your break. We'll see you in 5 minutes. Alrighty, let's start coming back together. All right, cool. So welcome back. Don't worry, this break was a little bit shorter. Trust me, the next few breaks will be longer. The standard one that we usually go with is about 10 minutes. So, let's see. So now that you guys have had some time to think or not think, not thinking during breaks is a healthy thing to do too. Do you guys have any questions about any of the stuff we talked about for the first hour before we jump into more JavaScript? Are character and string the same in JavaScript? That's a good question, Second. I'm actually not sure. From what I understand, though, I think they're different because strings are designed to be immutable initially, whereas if you have like an array of characters, then that array can be changed. So I believe that the two data types are treated as different. And yes, Jonathan, that's correct. So yeah, char is usually used for a singular character and string for one or more characters.
Yeah, just to pipe in, you guys can hear me, right?
Yep.
Yeah, I'm pretty sure JavaScript does not have true characters. It only has strings. And if a string is only one character long, you can call that a character. But it's not a character in the same way it is in C or something, where in C, you really have this concept of a character, and then you could have a list of characters and you call that a string, but it's not just like a string or just like a normal list, it's not immutable. So Java, just like in JavaScript, everything is a number. Both characters and strings are strings in JavaScript. As far as I know, there's no unique character type.
Gotcha. That's a helpful clarification. Any other questions?
I had a question about if you have something in scientific notation, how would you like convert it back to like the full decimal? I remember there was like a Code Wars problem I was trying to do, and I couldn't figure out how to get it just to print out, e to the 10th or whatever.
That's a good question. You should just be able to use number to do that. So here, let me back to share my screen here. So here we have like the I am a decimal thing, right? With the 1.23 to the -4. So if I put this in quotes and make it a string, which is probably what you saw in that Code Wars problem, I need to figure out how to turn it into a regular number. What you can do, I'll just console log it for purposes of this demonstration, is type number and then the string in scientific notation. So if we run that, as you can see down here in my console, we get the proper normal numberified version of it. So yeah, just plug it into number. Number will turn your string into a number. Any other questions? All right, let's go ahead and talk a little bit. I realized there was one thing I forgot about Booleans before we move on. And this is super important. So this is going to be the double equals versus the triple equals in JavaScript. So note that this is basically only a JavaScript thing. You don't really see the triple equals in Python. So but this is a really, really important difference. So keep that in mind. So the difference between the two is the double equals will perform something called implicit type conversion. So let's say, for example, that I have like a variable that has a value of like 12. And I want to check if this thing is equal to a string that has 12 in the string. So if I console log this guy, and let me just move this and just say convert side note to normal number. So if I were to console check, hey, is 12 equal to the string 12 and run this? As you can see, JavaScript says this is true. So the 12 equals 12. However, the number 12 and the string 12 are two different types, right? And I can verify that by saying, all right, console log, give me the type of 12 and console log type of 12, right? So if we run that, again, we see this 12 is a number. Well, the 12 in quotes is a string. And this is where the triple equals comes in play. So if we run 12 triple equals the 12 in quotes, we get false. But don't both the equals and the both equals formulas tell us if things are the same? They do, but the main difference between them is that this double equals, again, performs this implicit type conversion. So it'll say, all right, I'm going to forget that one of these is a number and one of these is a string. I'm just going to check, is the 12 equal to the 12? Yes, we're good. However, the triple equals is like, all right, I have a number that's 12 and a string that's 12. A number and a string are not the same, so this is false. So the triple equals checks if types are equal to, unlike the double equals. And for this reason, we want to stick with using triple equals. So use this one more. Or like, I guess I could say like almost always. And here's the other reason why. Sometimes, let's say that you're getting text input from a user, and you're telling that user to input a number in like, I don't know, in a form, and they hit enter. And now they submit that number. So let's say that they're reading in, you're getting in that number as a string. And you need to double check if the string that they're inputting is equal to 12, let's say, right? So this first approach, using the double equals, is like, all right, the input is a string. We're checking, is the string input equal to the number 12? Sure. However, if you need to use that string input as an actual number later, like let's say that string input of 12, you then need to like multiply it by 3 and divide by and subtract 7 or something like that. JavaScript's going to be like, you can't do that with a string. So it'll throw a more complicated error down the line if you use this double equals. However, if instead you use this triple equals, it'll say, hey, this is wrong. You can't compare a string to a number. And then you see that error, and then you're like, oh, I needed to convert that string input of 12 to a regular number. Let me do that. So that's why I always recommend sticking to this triple equals. So this is a really, really important difference that I want you guys to understand before we move on. Do we have any questions about the double versus triple equals for JavaScript? Will we be going over TypeScript? in a few weeks, I believe we should be touching on it. We won't delve into TypeScript significantly, but we will be going over it.
Yeah, we don't touch on it too much right now, but it's definitely the most requested thing. And I can tell you personally, like when I was in industry, I've only been using TypeScript for a while. So I mean, there's almost no downside to going from JavaScript to TypeScript. It's just more to learn. So we're definitely going to do our best during this semester to create some new curriculum so that we can touch on TypeScript more. And feel free, of course, to discover it yourself.
Yeah, as Benjamin said, again, if you guys are interested in learning something, feel free to bring it up with us instructors, or if you want to, feel free to go learn it on your own as well. You're definitely not restricted to just sticking to the stuff that we go over in class, like discovery on your own is something that we really, really highly encourage too. Okay, so if there's no other questions about Booleans, we've got a couple of other data types that I want to talk about. So the first one is the undefined data type. And this basically just happens when you declare a variable, but you don't set its value. So if I were to say, like, create a variable using, let's say, let car, and I'm just keeping it completely blank. Now, if I were to get console.log type of car, now I haven't said whether car is a number, whether car is a string, whether car is a Boolean. It doesn't even know. So if I were to run this, let me move my UR screen sharing up to the top. Again, it says the type is undefined because it doesn't know what car is. However, if I now set instead car equals room, let's say, and here let me put my semicolon there, and we console log the type of car. Now we see that now it's a string, right? So here it's undefined because it's not told what it is, but now we've defined it as a string because we set car equal to room, which is a string. So now we can say car type set to string. So undefined is helpful when you're just setting up a variable like that. Now we also have the null type, which is really similar. Then it lets you declare a variable with null inside it. So it's very similar to undefined, but it's got a slightly different format. So if we wanted to create a null variable, we could say like let car2 or boat, another thing, equals null. That's all we have to do. And then if I wanted to console log the type of boat, and we run it, it'll say that it's an object, and this object is a null type. All right, let's see. So those are all the primitive data types that we're going to have to deal with. So we can go ahead and talk about some complex data types now. So for complex data types, we have arrays are a pretty big one. So arrays are basically, the fancy definition is that they are an ordered list of values. So what does that mean for us? When we're creating an array in JavaScript, we're going to initiate it by putting it in square brackets, and we can put our values using a comma separated list, and so on. And also don't forget that these are 0 indexed. So we can say value 1, value 2, and so on. Roger, yes. So lists and arrays are two different things. I won't go into the differences of what they are right now, mostly because it doesn't really matter for purposes of this week. But one thing to keep in mind is some languages do have both lists and arrays, like C and some packages of Python. Arrays are generally known to be more structured than lists, and they have additional restrictions on them. Like arrays will often be like memory capped, while lists are less so. So they are two different things. But just note that JavaScript uses arrays, Python uses lists to keep it really, really simple. So yeah, again, so JavaScript arrays are going to be our ordered list of values. They are 0 indexed. So that means when we start out by accessing our elements, we're going to start at index 0. Then we can access elements through index reference using, here, let's just say this is like list 1. We could say like list 1 index notation. And what else? Oh yeah, and the values can be any data type, which I think is super handy. So much like strings, arrays have a bunch of different data types, or different methods that are associated with them. Mozilla has a really good reference page for this. It's probably on the README somewhere, and you can also look it up if you need to, but there are a ton of different array methods. But let's just see how these work in practice. So let's create, let's make an array and we'll call it let array1. Let's change this from list to array. So I'll say array1. This could have something like 1, 2, 3, 4. Let's say it's an array of 4 numbers. So we can do is we can console.log array1.length. I can get the length of this array, and it's got 4 elements in it. I can console log. So this is number of elements. I can also push something to the array. I can do array1.push, and I can add on, let's say, an element. I'll call that, like, let's say I want to add on a 5. I can pop on a 5, and then it'll return the thing I pushed. So if I go console log array1 now, we see that array1 now has a 5th element that I'm calling 5. Let's see, what else can we do? We can also, let's see, pop things. So if we do array1.pop, and we can remove the last element from an array like so. Okay, let me just remove that. So that way that'll remove the element 5 that we just pushed to it. As you can see, so it says 1, 2, 3, 4. We can console log, let's see if this will work. We can splice an array. So much like for strings, where's the string bit? Where we have string slicing, we also have array splicing, which will basically remove elements from an array. So if you want to, let's say, splice, I can start, like, let's say I want to remove 1. I can splice starting at index 1 and remove, let's say, the next 2 elements. And we run that, then it stops here, and then it takes the 2 elements 2 and 3, and it outputs those. again, there are a bunch more array methods that we can use as well. I don't remember what they are off the top of my head, but rest assured they do exist. And you can reference them using the Mozilla guide or the README. But these are some of the ones that we're going to be using fairly often. Any questions about these array methods before we move on to objects or about arrays in general?
Yeah, I have a question. I'm trying to, evaluate like two arrays, just saying that array like 1 equals to array 1, but just keep giving me like false. Is my computer broken or is it just normal? Like was a triple equal sign like this?
Yeah, that's a good question. So if you want to check if two arrays are equal, you don't want to use the you don't necessarily want to always use the equal signs to do this. What I would recommend is using a loop. But also here's the other reason why. So let's create two arrays. So we've got our let me comment this out. So we have our array 1, which is 1, 2, 3, 4. And let's create an array 2 that is also 1, 2, 3, 4. So just to make sure, Islam, what you're doing is you're saying array 1 triple equals array 2, right? Like this?
Yes.
Okay, so if we run that, it gives us false, which makes absolutely no sense from our perspective, because triple equals supposed to check whether the two arrays are the same. The reason that this doesn't work is because the 1, 2, 3, 4, the two arrays don't have the same location in memory. So though their contents are the same, their memory locations are not. So this is false. So how can we check, therefore, if two arrays are the same? Well, the easy way to do it is to go element, or I wouldn't say easy. The way that makes the most sense is to double check each element. So you can write a for loop and you'll say, okay, I'm going to start with index I equals 1, or I equals 0, I less than the length of the array, I plus plus, and then say, is the element at index 1 of the array, of the first array, equal to the element at index 2? If it is, then we're good and keep going. If they aren't equal at any point, then return them not being equal. So does that kind of make sense?
Yes, it does. But is there any simpler way? Just besides doing like loop around,
Not really. And the only reason for that, I mean, there are packages, I'm fairly sure, that have functions to do this. We'll see some of those later on, but to be honest, it's generally better to just handwrite those functions. But yeah, there isn't really a built-in way to check array equivalency in JavaScript, unless you want to make it more complicated.
Yeah, it definitely is a worthwhile challenge to write it on your own if you're trying to write like a function that checks deep equality for arrays. So not just basically that they contain the same thing, what they contains the same thing. But I can share a link to it. The library I was using as an example for the library I've been using as an example for like GitHub stuff, I'm sharing it right now, is called Lodash. Lodash is everyone's favorite JavaScript utility library. So everything you could want, like checking deep equality or anything else that's not built into the language, but is like really useful day to day, it's in there.
Okay, that's super helpful. Thank you, Benjamin. I didn't actually know about that library, but that seems like a very useful resource for us to use.
If you might know about underscore if you're a JavaScript person, right? So Lodash, as you could tell, like underscore Lodash, same idea. That the underscore team had an internal squabble and they broke up, and it's two separate projects now. So that's why I just prefer Lodash.
Cool stuff. So also, before we move on, though, there is something that I want to address, which is something that Rob brought up in the chat. So Stringify is an option that we can use. However, I would strongly caution against using Stringify for array equality. And here's why. So if you have, let's say, instead of numbers, let's say that you have an array of class objects, for example, and those class objects don't have a string method attached to them. And this is something we'll get to in a few weeks, so don't worry too much about it. But basically, if you have an array of things that cannot be stringified, because JSON.stringify turns whatever's inside your array into a string. If it can't be turned into a string, then you're going to get problems with array equality. So it's a bit more of a niche use case than what we're talking about, but that will become very much not niche in like 3 weeks or so. So because of that, I would highly recommend against using the stringify and instead looking at something like Lodash or just going elements by element through a for loop and checking, whether the elements are the same. Stringify is an option, but it sometimes doesn't work. So yeah. Okay, so that's all I have for arrays. We can also talk a bit about objects. So what are objects? Objects are essentially a collection of key value pairs. So what does that mean for us? Well, these are not index accessible. So not like arrays. And they are not, let's see, they aren't ordered as well. So not ordered. Also, unlike arrays. Yeah, that's about it. So if we wanted to set up an object, let's say we have a const. Let's say that we have a car. So we'll set this to the equal sign. And instead of using square brackets like we do for arrays, we're going to use curly brackets. What are some characteristics of a car?
Horsepower or miles per gallon?
Wheels?
Sure. All right, so let's start. So horsepower, let's say, is going to be like 400. This thing is absolutely insane on the road. Miles per gallon. Yeah, so we can say miles per gallon. Let's say it's also super efficient or inefficient. Don't know why. We could also put down like manufacturer, and we could say, sorry. Okay, so we could say like the manufacturer could be like Ford, and we could say like is owned as a Boolean, and we could say that that is true. So super simple way, if we have an object that we need to describe multiple features of, we can use this object notation to do that super simple. So now that we have this car, let's say that I wanted to find out what the car's manufacturer is. Well, I could do car and then manufacturer, get the value of that property, and we can see that the car's manufacturer is Ford. So we're going to access the value of this object. We can either use the use this notation, just like with arrays of square bracket access, or we can also console.log car.manufacture if we want to access it, if the name of the property that we're accessing is a string. So also do note that because objects are key value pairs, the key does not always have to be a string. So I can set the key to be like a number, and it can be referenced to like hello world or something. And let me put a semicolon there. So if I wanted to console log cars 12412, for example, then it'll get us our hello world out there. So keep that in mind, that objects key value pairs are not only restricted to the keys being strings. And Jonathan, yes, objects in JavaScript and dictionaries in Python, for all intents and purposes for the next 2 days, are basically the exact same thing. Okay, so something to note about objects as well is objects are mutable. So you can change the values of keys. So let's say that this car isn't, let's say the car is miles per gallon. We actually put it in wrong and it's 15 miles per gallon. We can say car.mpg is now equal to 15. And if I were to console log cars mpg, we now see that the miles per gallon has updated to 15. And we can also console log the whole object car as a whole. And if we do that, let me move my terminal up just a tad. We see here that it outputs it in this very nice format. It puts out, I guess, orders it somehow when printing. I'm not sure how it does that, but it puts it into a little order, and it prints it out with our key value pairs very nicely. So Jonathan, good question. Either one is perfectly fine. Car with the manufacturer and quotes is also okay. The dot manufacturer will only work if the key that you're accessing is a string. So if the key that you're accessing, for example, was a number, the car dot would not work. And the syntax would just look really bad. So it's up to you whichever one you'd like to use. Personally, I like using the dot notation as much as possible because it's similar in Python as well. But that being said, you're more than welcome to use the bracket notation too. There's absolutely nothing wrong with it, and it can sometimes be a good thing. Any other questions? All right, so Jesse,
you don't put semicolons on the after your lines. Is that just like a preference, or again for notation, semicolons at the end of lines?
So it's a notational thing. In general, it is a good practice to do that, so I should probably be doing it. But the benefits of putting semicolons on the end of your lines is so that if, let's say, you can't run all three of these in the same line if you have semicolons separating the statements, like so. But if I were to remove these semicolons, I would not be able to run all of these in one line. So for example, like if I'm typing like this, let's say, and by accident, like my hand hits the delete key and I keep working and I run my code, it'll still work when I have the semicolon there because it uses the semicolons to delineate between each JavaScript expression that I'm running. However, if I was doing what I did before, and again, I don't have the semicolons, and I just hit the delete button, and I keep typing, as you can see here, it throws an error, and it says that a semicolon is expected, because it can't separate the two from each other. So hopefully that helps a little bit. All right, let's see. Any other questions?
Yeah, for the key in the JavaScript, what do you call it? What do you call it? Is it dictionary object? Do you have to put quotation marks or not?
It depends.
For example, in the
So
Python, you can use like variables instead of putting the key, for example. Some kind of,
yeah.
Can you do the same thing here?
So there you can do that with the dot notation. You don't need to use the quotation marks. But with the bracket notation, you do need to use the quotation marks.
No, actually, while I'm actually setting up the dictionary like this, in Python,
He
you can
means in
use
the object, in the
yeah,
object
Oh,
itself.
object
okay.
itself. I can use variable as a key. Can you do the same thing with JavaScript? Like horsepower probably it's defined somewhere up and just want to use it, like, or
Yeah,
maybe
so.
like let's say important feature. Let's say put like important feature and somebody user defines that important feature like before actually setting up the object.
So what you're talking about is something like this. So like I'm defining horsepower up here and then also using it down here.
Yeah.
I'm not sure actually, but let's check. So if I run this and we remove that from our console logs, let's see. No, so that doesn't work. So the horsepower here is just going to be the string horsepower. And I think the reason for that is because I think the reason why that happens is because this is going to be locally defined within the context of the object. But also, if I just type something in normally here, it'll automatically assume that this is a string and not the variable. So it'll override it and make it a string, if that makes sense. Because as you can see down here, when we're accessing things, the base way to access a key value pair is by putting the key in quotes. So it'll automatically turn it into a string when you put it in there, which will sort of break it from the variable, if that makes sense.
Yeah, you are correct that to whoever asked the question, or Islam John, you're correct that in Python it makes you it makes you write the key as an actual string, and in JavaScript it lets you kind of leave off those quotes for simplicity. But in terms of what Umar is describing, yes, that variable horsepower and when you're defining, horsepower : 400, those are going to be treated as separate things. But Umar, try this. Go to your car object definition and remove just the 400 and the colon next to horsepower. So just have horsepower there. Okay, now save it and run it so that you could see it. So now it'll have room in there. And if you do that, that wasn't originally in JavaScript. That's an ES6 feature, which is like an update to JavaScript that happened in 2016, I think. But that feature makes it so that if you have a variable, you could easily put the name value pair of the variable right in an object. So sometimes that's useful.
Ah, that's cool. Thanks.
That is actually really cool. I didn't know about that. Thank you, Benjamin. So yeah, I guess you can insert variables like that into your objects. However, also when you're doing that, note that if we were to write, say, console, we could still access horsepower, like the global that we defined, as horsepower, like so. But if we wanted to access it within the context of car, we would still have to access it either using the dot notation or using the brackets and quotation marks, because now it's been sort of turned from a regular variable into a key value pair for purposes of the object. Okay, any other questions about objects?
If there's no other questions, I just want to clarify based on what I said, just to make sure. That when you write like horsepower there and it puts vroom in there, that's a one-time thing. It's not like that horsepower is always tied to that variable, and if you change that variable, it'll change what's in the object. It's literally just a one-time what's in there. Now there's a new, field in your object called horsepower with a value called vroom, and then it doesn't care about that object or that variable forevermore. It's not like they're linked or anything. Just want to clarify.
Thank you for that clarification, Benjamin. And if we wanted to like visually confirm that, we could also say like horsepower equals like 1,000, 10,000 now, or 1,000. And if we run this, if the two were still linked, we would expect that the value would update inside car. However, horsepower is still vroom. It hasn't changed to 1,000 or thrown us an error. So the two they're linked at time of creation in car, but after that, no more. All right, same question as Rob. Let's see. Is there a way to get the key if you only have the value? So yes, and as Rob stated a little bit further down, you can use the entries and find methods to do that. But as Benjamin said, that's not really how the key pair value / dictionary concept works. So the way it works for us is to, again, we have keys, you own it's designed so that you access the values using the keys, not the other way around. So there is a way to do it. It's a little bit complicated and not very fun. But yes, you can do it, but we won't be talking about that just right now. Okay, any other questions for me about objects before we move on to functions? Okay, so let's talk a little bit about the basics of functions, and then we'll take a 10-minute break, and then after that we'll continue wrapping up functions and move on to rejects, one or two other topics, I believe, and then we'll wrap up with this morning's lecture portion. So let's create a block for functions, and let me comment all of that out and comment this guy and that guy. Just make sure that we don't have any print statements that are meant to be running right now. Perfect. All right, so let's talk a little bit about functions. So again, simple stuff. Functions, you take inputs, you pass them to the function, it does stuff, and it gives us outputs. So what's the format for creating a function in JavaScript? Can anyone tell me?
You can first start off with the function keyword.
All right, yep, so we got the function keyword. Again, just like when you're creating a let or a const, you can do function in the same way. Then we can create the name of the function. We can call it like my function. Then you have your input 1, let's say, and then I'm going to use curly brackets, and then we just do stuff inside of our function. So this is the general format for a function that we'll use. Note that the inputs to your functions are copy by value. So what does that mean? Well, if we decide that we want to change the things that we're putting into the function, it will not automatically change those if we don't return something. So let's say that we have a function called multiply by 2, and we can say that the thing we're putting in an input number, and we can now, let's say that we said input num equals input num times 2. So if we, no, not constructor, let's say we console log multiply by 2 of 5. Or actually, sorry, well, let me change that. We'll multiply, let's create a let number 1 equal 5, and we'll multiply by 2 number 1, and console.log number 1. So this still gives us 5, which doesn't make very much sense, because again, based on what we're saying here, it should change the 5 to a 10, right? The only problem is it doesn't. Why? Well, the input num in here, it copies the value of number 1. It copies the value of 5. It does not actually change the 5 contained in number 1, which is our problem. So if we wanted the function to actually change the number, then we have to do something a little bit different. So this not change number, because only copy value change, not actual input. So how can we rewrite this function in order to actually change our number? So let's copy this down here. Instead of saying the input number equals that, we're going to instead return the input number times 2. Let me just reorganize this a tad. So console log that, and that one again we said doesn't work, and we'll say this is multiplied by 2, let's say working. So what's the difference between these two? The difference is we've introduced this return keyword, which does not change the input, but this creates an output for us. So whenever you have return lets your function spit something in. So if we were to console log, let's say multiply by 2 working of number 1, now that returns 10. And if we wanted to actually update the value of number 1, what we could do is say number 1 equals multiply by 2 working of number 1. So now this will change number 1 from 5 to function output of 10. And let's just double check that that's actually true. It is true. So if, again, we cannot change the value of an input on its own, but if we decide that we need to change the value of that input, we can use return and then set that value to whatever it is we need to outside of the function. So any questions about that?
Yeah, I have a question about that. Is it making a copy, or is it just because the value is a mutable type? Or is it an immutable type?
I believe it's because it's an immutable type. And we will get to that in just a second. So for immutable types. So that is actually a very good question. Here, let me comment this part out. And now let's try doing something with a mutable type. So for something like a mutable type, let's say that we can create, let's say that we can, well, let's experiment with, well, let's use an object, let's say. So if we have let a new object be like, thing 1, 1, thing 2, 2, thing 3, 3, let's say. And now we're going to write a function to change thing 2, and we'll say we'll input an object in that function, and we could say object dot thing 2 equals like 10. So if this had the same behavior as we just talked about for our immutable types of, let's say, integer numbers, right? If we ran, here, let me say, change thing to new object, and if I ran console log new object, if it did the same thing as earlier, this would not change the inside of new object. However, because this is a mutable type, because the type itself is mutable, if we were to change the input, this makes it a copy by reference. So you can change the input by default. So does that kind of make sense, Eric?
Yeah, I think so. So if you were to pass in like an object or something that could actually be mutated, then it would actually change it, the object that you passed, right?
Yep, or it wouldn't change it necessarily, but it gives you the option to change the value of that input.
Right, okay.
Yeah, what you said earlier is exactly right. It is directly related to whether something is mutable or immutable. If something is immutable, it has no option but to, the only way to share it would be to say, I made a brand new copy, here it is, because I can't just give you the memory address of this because you'll you'll modify it. Whereas if something is mutable, especially because mutable things tend to be bigger, they're like objects or arrays, it's passed by reference, meaning we give you the memory address, we give you where it starts, and then you do what you want with it, you are mutating the same thing. And the reason for this is basically that if you're trying to share a number with a function, so you pass a number as a parameter into a function, that's pretty simple to do the copy. So if something is a primitive, it's small, doing the copy is pretty simple. Whereas let's say I passed in an array or an object that represented like a 16 gigabyte movie or something. If I had to copy that before passing it in, it would be incredibly slow. So you pass it in and you're saying, maybe someone will even write on the function, please do not modify this. But because you're passing it in simply by the memory address, that's quick to do. And then someone, as a result, has the ability to modify it.
Can you force it? Like, for example, like constant, when you give into function, just force it without trusting it.
Can you force it?
Not to modify it,
In JavaScript, not really. In some languages, yes, you could say, hey, I'm passing this in as a reference, but you do not have the right to change it. In JavaScript, because JavaScript is so loosey-goosey with a lot of these things, not really. The answer to that would be this this thing called object.freeze, or I think array.freeze. And that is a way of saying this object, no matter how I'm passing it around, no one has the right to change this anymore once it's frozen. But that's like a pretty, you don't see that too often.
Yeah, thanks.
Any other questions about functions or mutability of objects before we take our break?
I actually had a question just as a definition of an input versus an argument or an element? Just all inputs and arguments the same necessarily?
Yeah, pretty much. The words are interchangeable. Function arguments are the things you put into the function. Inputs are things you put into the function. So for all intents and purposes, you can use inputs and arguments the same way. Generally, I feel like I've seen inputs and outputs used more in the context of like the black box analogy that I'm sure you guys have encountered at some point, where it's like you have inputs and then the black box of the function and then outputs. But you can also, the equivalent model is, you have arguments getting passed into the function and then return values. So yeah. And yes, Eric, that is correct. So yep, you pass the arguments into the function and you declare its parameters.
I have a question just to clarify. So like in the
Sure.
first example, you're not returning anything, so that's why it doesn't change the number since it's immutable. But then the return, is that just making another like reference or copy?
So both of them are still copies. So when you create, like when I've created this input num is not the reference of number one. Like when I pass number one into that function initially, it's copying the value of number one. So it's saying like multiply by 2, 5. So that copies that value in. But when I put down this, so because it copies that value, it can't change like the true value in number one. It can change 5 and it changes to 5 in there, but it doesn't know what to do with that. That's not the same as the number one like thing. However, when I have return here will basically create a new output for us. So it creates the output of 10. And now down here, when I say number one equals this new function, and this new function outputs 10, then this whole expression essentially evaluates to 10. So I can change the value of number one when I go outside of the function, if that makes sense.
Okay, yeah, that makes sense. Thanks.
Other questions? Okay, if not, let's go ahead and take a 9-minute break. Apologies. And we'll come back together at 10:50. So again, if you have questions, pop them in any of the myriad chats and see you guys in 9 minutes. Alrighty, let's start coming back now.
So I have a question about function parameters. So
Go for it.
is it safe to say that if it's a small enough input, then the function creates new variables, and if it's a large object, that passes by reference because it's just too big of an issue to copy over? Am I getting that right?
Close. So you're right for the objects, it just uses the original pass by reference because it's just giant. But for a primitive data type, so number, string, Boolean, it creates a copy.
And it creates a copy to a new variable that's declared in the function parameter, that's declared as the function parameter?
Yes.
Okay, thanks.
Any other questions about the stuff we talked about before jumping into the newer stuff? Okay, if not, let me go ahead and just keep resuming the share. And okay, cool. Our recording is still going. Perfect. So the next thing we're going to talk about is something called rejects or regular expressions. So what rejects lets us do is it lets us basically find things in strings or do string matching. So used for finding things in strings / string matching / pattern matching. So for example, let's say that you have a list of like 30 files and you need to figure out which of those files is a Python file. Well, what you could do is go down a list of each and every single file and check, okay, does this have does this end in .py? Does this one end in .py? Does that one end in .py? And keep doing that. But that kind of looks a little bit cumbersome when you write it out in a for loop. So instead of that, we can use rejects or regular expressions to do pretty much the same thing. So there are a lot, and I mean like a lot of regular expressions, and the syntax is super confusing. So for purposes of today's demonstration, I'm only going to go over like a couple of real simple use cases, but the README and the rejects documentation, which I'm fairly sure is linked in the README too. If it's not, I can send it to you guys after. That goes into a lot more depth. So feel free to check that out if you want to. You'll probably need to for tonight's exercise or this afternoon's exercises. So the way we define a regular expression, let's say, here, we'll just call it rejects, is using something called a regular expression literal. So the way we set this up is by using some slashes, not two in one sequence. That's the way you do a comment. But then you can start typing things inside it. So this is, let's see, here, let's make a string. So we can say constant string we are using. Let's say we could do like BC 1 2 3, AB 1 2 3, BC A B B B C. So let's say that what we want to do is find everything in our string that has the goal, find everything in this string with format A, B, and then more B's, and then a C in it. So what should, if we were to write a function that finds everything in that string, it should give us this ABC and this A, B, 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 C bit, right? So how can we write some regex to do this? Well, first thing we need to do to set this up is use our 2 slashes. So what this part does is it will match the string, whatever we put inside these two, it'll match that. So if we set regex equal to slash AB and then closing slash, it'll match all of our substrings with an AB in it. Next, we can put in a star, and that star basically says match A, B, and then a bunch of other B's. And then we can put a C. So it'll say it matches A, B, or BB, or BBB, and so on, and then a C. And then at the end of it, we'll just put a G. So how do we actually use this regex pattern in our string that we're using? Well, we need to create a new, actually here, we can just console log this. We don't need to create a new variable. So we're going to say string we are using dot match, which is our function. And if you can see down here, it takes in a regular expression and it returns an array containing the results of that search. So our regular expression is going to be our regex. Let's save, make sure everything's commented out, and let me run that. So as you can see, it breaks this down into substrings delineated by the space bar, and it checks, all right, ABC. This has A, it has some B's in the middle, and has a C. 1, 2, 3 doesn't start with an A. AB 1, 2, 3 has A and B, but no C. This one doesn't have an A. This one has A, a bunch of B's, and a C. I'm going to return that. So this is, in general, how regex works. Now, in addition, we can also use the dot. So the dot in regex basically says I'm going to take in any character. So I could say AB star and then dot star, which says I can take in any number of other characters, and then the C. And if we run that, it'll return the whole thing. What if, let's say we did dot, dot, dot. That means we could do A, any number of B's, then 3 any characters, and then the C. And if we run that, we'll see that we get A, B, 1, 2, 3, C, and then we get A, B, and then 3 more B's, and then the C. So,
can you go over what the G means at the end?
Yeah, so the G just means that we're going to basically use this as a general format. And we're just going to run it through like the whole string and not stop at the first one.
Without the G, it would match the first one it found and then be done. With the G, it'll return you a list of all the matches it found.
Thank you, Benjamin. Any other questions about this part of the regex string that we've used?
So
and
for
also,
sorry, for that middle input or sorry, output, the ABC 1, 2, 3 that returned the whole string. Can you explain how that did that? Because I think when you typed in the regex, it was AB star dot star C, but it returned the BC portion of that string, but there's no A in the front of that, so I'm not sure. I'm just curious how that returned the BC.
So you're talking about this output down here?
I believe that was the one. Well, yeah, I guess I was looking at a different one, but it's the same thing.
Sure. So what does this whole command mean? So the important thing for regex is we need to break it down. So starting off, we're trying to, the slash means we need to identify. So we want to identify substrings starting with A, which is what the A part is, then some number of B's, then some number of any characters, and then a C. And then the G part means we want to identify all substrings. Now, this thing is going to basically start off at the beginning, and it'll say, all right, let me run through this. Now, because we've said it can have some number of any characters, because the dot means it can be any character we want. We know that this string has an A and a B in it, and all of these, like the C through this BBB, those are all any characters, technically. So because of that, this entire string satisfies this regex. So it's like, okay, since the whole thing satisfies it, I can just return the whole thing. Does that make sense?
Okay, it does, yeah. For some reason, I was thinking the spaces would create separate elements, and I was looking at the BC individually, thinking that it returned it for some reason. But no, the way you explained it makes sense. Thank you.
Yep.
So
yeah. Oh, go ahead.
The C at the end of the string we were using, if we didn't have that, then it wouldn't return that entire string.
Let's see. So if we turn this into a D, let's say, hypothesis that it'll probably stop here because that's where the last C is, but let's see. Yep, so it stops at the last C because that's what we said. We said put as many random characters as you want and then end it with a C. So the biggest thing it can get that still ends with a C ends here at this BC chunk. Any other questions about the regex? And also going back to what Benjamin mentioned and what one of the previous questions was, I don't remember which. But if we were to go back to our A, B, C and remove the G, then that would only return A, B, C to us. And we see that right down here. It returns it in a slightly more complicated format. It gives us a handy little format that says, okay, it gives us an index. It says this is the 0th substring. It gives us the full output. But in general, it's just a good format or good practice to have the G in there just so that you get this nicely formatted array. Yeah. Let's see. Are there any questions that you guys have about regex that I can answer before we move on?
I had a quick question. What's the difference between doing match in this situation and throwing the G at the end of the regex versus using like match all?
Oh, that is a good question. I'm actually not sure, but let's see. If we look at we start typing match all. It says match a string with a regular expression, returns an iterable of matches. Okay, so this is not an iterable iterator is not guaranteed to be an array. So if we did here, let's see if I can console log this and make sure that my hypothesis is right. Yes, perfect. So this does it returns a regex string iterator instead of an array like so. So a string iterator is something that we can put into a loop or something we can loop over, but it doesn't have a very handy visual format or something we can use. So that's the main that's the main difference between match and match all.
Makes sense.
You see it. Yep, no problem. So yeah, in general, it's just better to use match just because it's easy to read and use. Match all has its uses, again, if you need to iterate over a bunch of matches. But for at least for today's problems and for most of the times you're going to be using regex, match ought to work just fine. Other questions?
What are some common scenarios in which you'll need to use or would want to use regex?
A good one is getting email addresses. So if you have like well, let's say you have like a giant text document and you have like a bunch of email addresses and you only want to find the addresses associated with code platoon, let's say, out of like thousands of addresses. Then you could use regex to create a string that, let's say, what would that regex look like? Well, you could probably say like regex emails for code platoon would be something like this, and then G, and we would have dot star, and then app code platoon, and then .org, for example. So you could use this to find all the emails in a giant list that, or in a string that belong to code platoon. Or let's say that you had like a list of addresses and you wanted to find all the addresses that were in Illinois. You could do the same thing and just say match everything that has an IL in the address. So regex is really good for finding strings in other strings. It's also really good if you have different formats. So one of the challenges that you guys will either do today or later on is about finding and reformatting phone numbers. Because again, phone numbers, you can have like your format with the parentheses, with dashes, with spaces. So how do you handle that? No, regex can help you figure out how to reformat a phone number to one standard format. So those are a couple of good use cases for regex.
And what about like the I don't know what you call it, like the suffix, I guess. What about I?
How do you mean?
Like there's another one that's I. I don't remember what it stood for though. Like so
Oh, like in regex?
Yeah,
Yeah.
he's talking about the flag, I guess, like global.
Yeah, exactly.
Okay. I think the I is for case sensitivity. But let me look that up really quickly just to make sure. Yes. Okay. So yeah, so regex. So the I is for case and sensitivity. So if we did like an IG, I guess, and we change this to like AB123C. And we ran that again. So as you can see here, even though this A, B, and C in that guy are all capitalized, because we added the I, that forces it to be case insensitive. Because normally, regex is fully case sensitive. Like, if we ran this now, it would only give you the thing that matches the characters exactly. But when we add that I in there, it means, okay, I don't care if it's uppercase or lowercase. I'm just going to match everything that is upper or lower for that. And Jonathan, to answer your question, no, the order of the flags does not matter for regex. But the order of the things inside the search expression definitely matters. Flags don't, but the order of the search terms does matter. Any other questions?
Can we also use symbols in regex as well?
Yep, you should be able to. But just note that some symbols in regex have special definitions. So, like, for example, if you wanted to search for a star, you would not be able to search for the star in that way. You would have to, I think you'd have to use a backslash if you wanted to search for the star, like before it. So the backslash star basically means the star here does not mean I have a bunch of characters. The star means that I'm looking for the star character. So for regex, it's always important to keep an eye out for those special characters. There's a bunch. I would encourage you to look at the documentation to check about what those do.
Is there any other way we would use regex other than matching?
There's
You
test.
can use. Oh, go ahead.
There's test, right?
Yep, you can use it for test. There's reformatting strings, but that's also a matching thing. Yeah, that's really about it. There's not much else you can use regex for. But it's very, very handy at what it does. Any other questions? And okay, this is inaccurate, so that's 3 handy characters. There we go. All right, so that's regex. What other topics did we have? Let me just double check my notes here. So we went over variables, right? So we talked about const, which is once you set something with const, you cannot change its value afterwards. We talked about let, which is your normal variable definition. And we do want to talk about var. So var versus let and const. So most of the time we want to use let and const instead of var. And the reason for that is it's a little bit weird. So if we were to create a function or a loop and we use var in it, we would be able to access the variable var anywhere outside of the scope of definition. So how would so let's say that we had like a function called sum. It's just, again, it's following the README. So if we have, or actually sum is probably a bad one. I could say sum sum two numbers. And we could say n1 and n2. And then let's say that we created a variable for sum. And we said that sum equals n1 plus n2. And then we said return sum, right? So if I were to now say, let's say sum two numbers 12 and 14, but now I also said console log sum. Okay, well, it says sum is not defined. And I see why. Here, let's move this into our function. That's the problem. So if we run this, sum still exists inside of our function. It exists for the entire lifetime of the function, which is not great. However, if instead we were to do Let's go. Let me create another function that's similar. Actually, here, let's change this from sum to numbers. Let's just say sum function. Okay, here, let me change that. We'll just say sum equals n1 and sum function with let. Yes, so Eric, var has the problem with var is when you put it into a function, it can be used anywhere within that function. So if I were to say, let's say for some, or let's say var I equals 0, I less than 1, I minus minus, and I'll just say sum plus equals I. This is a way better explanation. And again, this follows what the README does. If you guys want to go back to that as well, feel free to. So we can console log sum, which is fine. But the problem is this I, which is our counter variable, still exists after our for loop. So if we say sum function 12, and we print this out, and okay, why did my var I equals, oh, that should be a plus plus, that was an infinite loop. Okay, there we go, that should fix that now. So we can see here that our I is still accessible even though it's outside of our for loop. So this causes a little bit of a problem because let's say that we create another for loop, let's say down here, it has the same variable name with I, then we might have some problems down the line. So the problem here is that we can access variable defined by var anywhere in scope of function. So that's the reason why we try not to use var. In contrast, if we were to, oops, let me copy this function over to do the same thing using let, and we'll say let, and rerun it. Now we get an error saying I is not defined. Why? Because let only makes I exist within its scope of definition. So access variable defined by let only in scope of definition. So that would be the scope of the for loop. As once we exit that for loop, I can make another for loop using I, and it won't have a problem with that. So var, you can access anywhere in that scope once you do it. And then with let, it's only in the scope of, in this case, the for loop, because the for loop creates a, I guess you could say a block for us. So it creates a block scope that we can use. So does that clarify? I know there were some questions about when to use let versus const versus var earlier. So does that clarify those a little bit? All right, I'm going to assume it does. So there's a couple other things that we should go over before I turn you guys loose. So one of those is going to be arrow functions. And Michael, yeah, basically do not use var. Stick to using let for things that you want to change. Stick to using const for things that you don't want to change. Forget that var exists.
And I've got another question. Let gives you a warning if you're gonna override it, right?
Yes, it does. And Grace, so to answer your question about why does it exist, legacy systems are not fun problem that happens. Especially since JavaScript is now going to have been around for 20 odd years, and var is probably still floating around in a bunch of old JavaScript code. So if you're dealing with like a legacy code base or an application somebody wrote like 20 years ago, and that still has a var in it, you can't remove those features with var, because that would break all of those old codes. So var still works for that reason. But please do not use var if you can help it. Any other questions about it? And again, the README has more details about other weird stuff that var does, if you are so inclined. But for purposes of this cohort, but also just good code practice, use let, use const, do not use var. All right, I'm going to assume that there are no more questions about that. Yes, great. So basically, you don't remove things, but you'll basically just say, hey, we have a new, better feature. Please use the better feature if possible, because it's a way better feature than the old ones.
The council has decided we're no longer using this.
Watch. Or just please use this, and threaten to deprecate support. It's generally the way it gets done. All right, so on to arrow functions. So for arrow, we've talked about your standard JavaScript function definition, right? So you've got function, name of function, and then you have your argument 1, argument 2, and then you have your brackets. So that's a nice way to define functions. But if you have a function that's like way shorter, or something that you don't need to make multiple lines for, we can use an arrow function to do this. So for example, let's say that we had an addition function. Let's say const add 2 numbers, and we'll use the equal sign now. So this add 2 numbers is the same thing as the name of the function. So now we'll define our inputs. So we'll say our arguments. So we'll say num1 and num2. Then we're going to use a fat arrow, which is the equal sign and then a greater than sign. So, and as you can see, if I mouse over this, it says, hey, I'm creating a new function that takes num1 and num2 and does something with those. And then from here, we can just say num1 plus num2. So this function is identical to add 2 numbers. We'll just say regular. We'll just say num1, num2, and then return num1 plus num2. So these two functions are the exact same thing. I can run so here we'll just say all the way. There we go. Identical in to arrow function above.
So does
we can
everyone
call it.
Sorry.
Go ahead.
Does everyone basically use const every time they do an arrow function? Because I see that a lot, and you don't really use let for it.
So the reason for that, again, goes back to the purposes of const and let. So let, when you define something with let, it lets you change the value. If you define something with const, you cannot change the value of it. So the reason that we use const for arrow functions is because the way you're defining an arrow function is basically like you're defining a variable and you're setting the value of that variable to a function. So it would be kind of weird if you could reassign the value of add 2 numbers later on, because it's a function. So that's why we used const, just so that we say like, hey, the value of add 2 numbers is not going to change. Can you talk about when you need to specify return? Yeah, so Kelvin, return is implied when using an arrow function. So arrow functions are basically really simple functions. So you don't want to use an arrow function for something that you have to write like 15 lines for. But if you're doing something for like string concatenation, for example, or writing a ternary operator or something like that, then return is implicit. And it really helps to make your code easier to read, decrease the number of lines. Because I mean, you can see for this one, like how long it is to just add these two numbers together. But this one is nice, simple, and condensed. And this is a format that we're going to see a lot when it comes to using JavaScript in web pages. If it's more than one line, do I need to return? Yes, that is correct. But generally, though, arrow functions, you really only want to keep them to one line. Because if it becomes more than one line, then, or like more than like 2 lines, I guess, it just becomes easier to create a real, like a regular normal function to use them. So again, since arrow functions are normal functions, just in a different format, I can use them just like a normal function, right? So I can add together these two numbers. I can add together 12 and 13, and I get 25. The same way that I would put them into my regular addition function. What else is there? Yeah, so we can also use arrow functions in other functions. So this is something that we'll get to a little bit later, but there's a function called map that basically allows you to run through an array and go through the array and perform operations on it. So while doing here, let's try that. So say we have an array of numbers equals, I'll just type things into my keyboard. It's negative 48. Yeah, that works. So what we can do is say, let's say that I want to create a new array of numbers, and we can say this array of numbers dot map. Oh, here, let me also put my semicolons on these, and we'll say this is a const, and we'll create this as a const as well. We can say that this is going to be, we take in an input of one number, which is our input, and we make it a fat arrow, and we say x plus 10. So what this does is, again, we create a new fat arrow function that just adds 10 to our input. This function does not have a name. So unlike for like a regular function, like here where we have to set up a name and multiple inputs and returns, fat arrow functions are anonymous, meaning they don't have names. So what this does is it's the map function again. It goes element by element through your array and executes whatever function it is you're running on. So this x goes to x plus 10. If we were to console log new array of numbers, it adds 10 to everything in here. Let's see. What other things are there that we can talk about? So yeah, map is one of your main examples. It's good to use for like hash maps. We can, let's see. Let me go to the chat real quick and see, because I just missed a bunch of stuff. Yeah, so we can talk about for each methods too. That's something that we'll probably talk about a little bit next week, if my memory serves me correctly too. So for each methods act somewhat similarly to a map. So let's say we can still use our array of numbers. So we could say, how do I want to do this? So array of numbers dot for each, and then we could, this one also has a this one also uses fat arrow functions. So we can take in an element and call it x, and then we could say we can console.log x, for example. So if we were to run this one, let's remove that just so we have a nice clean output. So this goes through our array of numbers, and it's going to console log the number in our array. So that's still there. That's why that seemed a little bit funny. So yeah, it goes 45, it console logs that, it console logs 12, it console logs -124, it console logs 48. So this one again just runs through your array.
I have a question.
Now yeah.
So you're basically using the map and the for each here for similar purposes, like you but like what's the difference between the two?
So the difference between them is what is returned. So as you can see here, it's a new array of numbers, right? If I'm creating array of numbers.map, that's creating a brand new array for us. However, if I were to say const another array, and that equals array of numbers, and we were to console log that. Oh, I need this file for sure. Let's change this to like x plus 2. If I were to do this, it returns undefined. So the for each function doesn't actually return you a new array, whereas map does. So that's a major difference between them. Another thing to keep in mind though is for each also does not change what is in your array, as you can see down here. I mean, for the record, neither does map, but for each again doesn't return anything either. So for each will just iterate over your array, and if you need to do something with those, it'll do it, but it will not change your original array and it won't return anything. Map doesn't change your original array either, but it returns a new array that is changed. And Roger, to answer your question, so the X basically just stands for your iterative variable. So if you look again back at what we did for this add two numbers, remember these two functions are identical to each other. So whatever is in the parentheses are your arguments. So just like we have num1 and num2 here, I chose to use X in this guy. X is just like your standard variable to use in a fat arrow function because it's one character, so it's real short, and fat arrow functions are supposed to be short. And X is always used for unknowns, so it's pretty much standard practice. But I could say that this is like array element, and I could pop that in here, and again, it works just fine. Gotta charge my laptop real quick. Give me 1 second. Perfect. So Jonathan, yes, so for each is only read map writes. And Roger, yes, you can use for each to add to a new array. Just not modifying the original. Any other questions about either of these two methods or for each?
Could you just do map for like most scenarios? Do you have to use for each versus map or one or the other?
Nope. I mean, I would generally use map more than for each, just because map actually returns a value, while for each is undefined, returns you an undefined. You can, there's no harm in, I mean, I wouldn't necessarily say it's good or bad practice to use one over the other. But they just have different use cases, is what I would say.
Thank you.
Any other questions about this? Okay, so if not, we've got a few more things, and then we'll get our lunch break. So the first thing that we're going to talk about is ternary.
I just
Oh,
wanted
go
to,
ahead.
to say that for the for each and the map stuff, don't worry about it too much now, because we're only introducing JavaScript a little bit now, and then it'll be mostly Python for a while. And we come back to JavaScript majorly when we do the React stuff. And then we'll really talk about this whole for each and map stuff and how it relates to this concept in programming called functional programming. And we'll go into it a lot of depth there, but it's not really something you have to worry about too much right now. Sorry to interrupt you, Mark.
Oh, no worries. That was actually very good for the folks to know. So thank you for that, Benjamin. Yeah, again, don't worry too much about the difference right now. But also, map is a function in Python. So now that you've seen it here, you'll see it again pretty soon, and you'll get a chance to play with it some more. It's not the same function, but it acts similarly and does something roughly similar. So it's good to familiarize yourself a little bit with it now. If there's no other questions on this, let's move on to ternary operators. So, actually, you nest. You could nest arrow functions within each other, I suppose. There wouldn't really be too much of a point in doing so, in my personal opinion, though, as again, arrow functions are meant to be short and condensed. So there's not really a need to nest them. And also, if you nested them together, you'd probably just be able to do the same thing in nested arrow functions as you would in just one slightly more expanded one. So is it possible? Yes. Would I recommend it? Not really. Okay, so now on to ternary operators. So for ternaries, they're basically replacements for your traditional if-else structure, right? So we could say like, let's say const, right here, we'll say let fave food equal grape. If fave food equals grapes, let me put my parentheses around those. Then we could say console dot, or we could say fave food equals, or we can just say let is it good equal yes. So we could say fave food here. We could say, let's say, is it good equals yes. Let me just do that. We could say else is it good equals no. So this is kind of long, right? I mean, we can see it takes 1, 2, 3, 4, 5, 6 lines of code to just evaluate whether if your favorite food is grapes, that means they're good. Otherwise, it is not good. So we can really shrink this down to a ternary. Now we can say let is it good equal, and then we're going to put in our condition, which is this guy. Then we'll say question mark, yes, and then colon, No. So these two do exactly the same thing. We're defining a variable called is it good? We're checking if the favorite food is grapes. If it is grapes, then is it good evaluates to yes. Otherwise, it evaluates to no. So the format of a ternary, as we've just seen, is going to be evaluating condition, true, false. So it's a lot simpler than having the whole if-else structure. It's really, really helpful to use if you need to base a variable definition on another variable. And again, they're just nice, quick, and simple to use. So you can also combine these with things like maps and ternaries if you really need to condense stuff down. So yeah, questions about ternaries?
So how would that look if you're like, say you have an if else statement that has multiple else statements? Could you do that same thing with a ternary?
You could, but it starts to get a little bit longer though. I'm not sure that personally I recommend using multiple ternaries like that. What would one look like? I'm trying to think about what the format would be. Yeah, so I mean, we could say, we could add in another one. We could say fave food triple equals pizza, and then question mark, say maybe, and then no, like so. So then this would basically be like your elif, your else if statement. So you say like else if fave food triple equals pizza, and then that would just be is it good equals maybe. So you can use it, but you can see how it's starting to get long once you have more than one condition. So then if you have like 4 or 5 of these, it's just better to just use a normal if else statement structure. So you can do it, but I don't know if it's necessarily the best idea.
Okay, thank you.
Any other questions?
Can you use like or
What do you mean by that?
like comparing two conditions?
Oh yeah, so you mean like if you wanted to combine these two like into one condition? Like that?
Yeah.
Yeah, so you can do that. If you wanted those to evaluate to the same to one thing. Just like you can in a normal if conditional. Because all it's saying again we're just putting in an evaluating condition. That can be anything that evaluates to a true or a false. So that can be a simple triple equals, it can be an and, or, not, exclusive or, combination of all of the above. It's really however you want to do it. But again, the main goal of ternaries are to be shorter replacements for if-else statements. Okay, so there's a couple of other things that we can talk about. One of them is loops. So I'm sure by now everybody knows a standard for loop format, right? So we could say for let I equal 0, I is less than 10, I plus plus. Then we could say like console log I, right? So this is just like your standard format loop. It's something that I'm sure we've all seen a few times by now. But let's say that we want to iterate over an array, looping over an array. Here, let's say that we have our array of numbers that's still here. And we comment some of these print statements out. That has 4 elements in it. So we could say is for let I equals 0, I is less than array of numbers dot length, I plus plus, and we can console log array of numbers I, right? So this is one way that we can get every, or go through, iterate through a list or an array and get every single element of it. But there's another way that we can iterate through an array. And it would be by saying for let number of array of numbers. And we can do console dot log number. And we'll see here, this does exactly the same thing. So what's the difference between this approach and that one? Well, this is the standard looping approach. This one goes iterates over every index, whereas this approach iterates over every element. So let me clarify what I mean here. So the first one, where we create a let I equals 0, I less than array less of numbers dot length, that goes like I equals 0, I equals 1, I equals 2, and you can use that I for whatever you want. In our case, we're using I as the index of this array. However, for the second approach, this for of loop, let me just call it that, for of loop. This one, it explicitly goes through every element of this array. So it starts off at 45, and then it goes to the next element of 12, goes to the next one of -124, goes to the next one of 48. So that's the main difference between these two methods. Another thing to keep in mind is the first approach, it lets you iterate over every index, so you can change the value of the array at that index. However, in a for of loop, because it iterates over every element, you cannot change the value of the element being iterated. So if I wanted to say, let's say like number equals like 5, for example, this approach would change it in here, but it's not going to change your original array of numbers. Let me prove that. Here, let me comment this out. So again, it changes number inside our loop, right? But it's not changing our original elements down here, even if we want to. So this is a really crucial difference between iterating over the indices versus iterating over the elements. Any questions about the for of loop versus our regular for loop that we talked about? And Roger, what do you mean by it gave you the index instead of the element? Would you mind elaborating? Also, I think you're muted.
I'm sorry. Yeah.
No worries.
I don't know what problem I was doing, but I used a for of loop, trying to iterate through, I don't know if it was a string or an array of numbers. It was something, but instead of giving me what I was trying to iterate through, it gave me the index of it. I wish I could explain a little bit more. I don't remember exactly how I was doing it. I just remember it wouldn't give me what I wanted. It just kept giving me the index of what I was trying to iterate through. Is there any way that could happen, or why it would happen?
It could happen if you are iterating over a list of indices, I suppose, or maybe if you were iterating over an object, but I'm not sure. That seems a little bit weird.
Is there any chance of doing a for in loop as opposed to a for of loop?
Yeah, I think I probably typed it in.
Yeah, no, it's definitely confusing because in Python it's for in, and really everyone wants it to be for in, but for in was taken by a previous feature in JavaScript that people almost never use. So now it's for of, but for in, it basically assumes an object and will loop through its keys. So if you give it an array, the keys of an array are its indices. So yeah, that's likely
a little bit inside. Yep, that's exactly what happened.
Yeah. Yeah, no, it's a little annoying that there's so much like someone's asking, can they not update the feature in JavaScript? The problem is they don't want to remove, if something already exists, it has to stay exactly as it already is. So they will add new features, new keywords, but they won't remove the old ones. And it makes it a bit uglier of a language. JavaScript is so much better today than it was like even just like 6 years ago. It's kind of I doubt Umar went into it this morning, but one of my favorite things to talk about is the actual history of JavaScript because it's nuts. The whole thing, JavaScript was originally made by one guy, supposedly over the course of like 8 days. And he tried to tell his bosses like, no, this isn't ready. I'm telling you, this isn't ready. And they're like, we don't care. It's going in. And it's just a fluke of history that it became the language of the web. It's not a well-designed language in the way that Python is a well-designed language. It just is what it is at this point. Yeah, no, it's a nuts story. Also, the reason it's called JavaScript is because it's a marketing thing. Java was a popular language at the time, so they're like, let's call it JavaScript. And everyone's like, but they're not the same. That's just going to confuse people. But some marketing people won out. It's the history of JavaScript is the story of like how to not how to design something to be useful in the next month and not really think about the next 20 years. Whereas Python was made by a guy who really knew what he was doing. Not that the JavaScript guy didn't, just hard to make a language. Yeah.
I actually encountered this in my technical interview because I was trying to use a for in loop on an array, but I learned through the technical interview that using a for in loop, it's meant to enumerate objects. So it'll give you like the key and the value, as opposed to like if you use it on an array, it'll give you the index, but it'll also iterate over any non-indexed values.
Yeah. And that's because at the end of the day in JavaScript, almost everything, including an array, really is an object. And also like the for in loop in JavaScript is almost never used. That's not such a useful thing to iterate through all the keys of an object. It's just what it is. So for of you'll use all the time, and you just have to get used to choosing the right one.
Yeah, thank you for that explanation, Benjamin. I actually did not know that much about the history of JavaScript, so we'll have to. I went over like a little bit of it this morning, but we'll definitely have to hear more soon.
Yeah, no, it's just a roller coaster ride of like, then they did that, then they did that. It's just my favorite thing is I mean that the whole this won't be accessible for most people, but the whole problem with var as opposed to let is this idea called dynamic scoping. And JavaScript was the first language to use it since the first version of Lisp, one of the first programming languages of all time. And Lisp version 2 took it out. So it's like, it's been known to be a bad idea since like the 50s. And yet he decided to go with it. And like everyone suffered for like 15 years until they sort of replaced it. But yeah, it's a roller coaster of bad decisions.
Interesting. But yeah, so going back to the one quick question about for in loops, and again, Benjamin, thank you so much for helping clarify that. So here I've just got like a small little object thing with a name and an age. So what we could say is for like let key in object thing, and we can console log object thing at that key, and it console logs Bob in 12. So that's the only real use of the for in loop, as Benjamin said, was to iterate over objects, iterate over key value pairs in an object. Nothing else to it. So to recap, your for loops go index by index or thing by thing. Your for of loops go element by element, and your for in loops go key by key. So we're not going to use the for in one that much. Again, as Benjamin said, it's not super helpful. The for of loop and the for loop are what you're going to use a whole lot more. That's pretty much all I've got for this morning. So before we break for lunch, does anybody have any questions about anything we talked about? And to recap, we started off talking about data types with primitives and more complex data types. We talked about strings, numbers, booleans, undefined, null. Then we talked about arrays, and objects. We talked a bit about functions and how they're different for copy by value versus copy reference for mutable and immutable types. We talked about rejects. We talked about do not use var, please only use let and const until probably for a long time. We discussed arrow functions, ternaries, and the 3 types of loops. And Dale, sure, I can send a copy of the doc in the Slack channel if you guys want. So any questions for me about any of this stuff? All right, so let's go ahead.